Okay guys, I wanted to go over how to calculate tube feedings, and in this case we've got a sample tube feeding order of Gevity 1.2, and that's going to be running at 75 mils an hour for 20 hours. And what we need to calculate are the calories that are being provided, the protein that's being provided, the total volume that's provided, the total free water, calorie to nitrogen ratio, and then we need to determine if the RDI for vitamins and minerals is being met. So we have the sheet that's provided by Ross Labs that you can download online, and we're going to be focusing, as a reminder, on the 1,000 mil column so that everything in here is in terms of liters. It just makes it easier to do it that way. The other things I want you guys to that we need to get from this sheet is we need to know the caloric density. We also need to know the calories and or the mils needed to meet 100% of the RDIs. We also need to know grams protein in terms of liters, and we need to know grams of water in terms of liters. So when we look at these, we know that the caloric density is 1.2 cals per mil. We need 1,200 calories or 1,000 mils to meet the RDIs for vitamins and minerals. Protein per liter, there's 55.5 grams of protein, and there's 807 mils of free water per liter. So, knowing those numbers, we can calculate all these other items that we need to calculate. So the first thing we're going to do is determine the total volume. And to do that, all we simply have to do is take the rate that we're running the tube feeding at times the total hours that it's running in a day. And so we're going to take 75 mils times 20 hours, 75 mils per hour times 20 hours, which is going to give us 1,500 mils, and that's total volume. Okay? Now that we have our total volume, we can calculate the total calories that are provided. If we have 1,500 mils, and we multiply that by the caloric density, which, if you remember from this page over here, is 1.2 calories per mil, then that's going to give us 1,800 calories. Okay. For protein, if we come back over and look, per liter, we have 55.5 grams of protein. So if I take 55.5 grams of protein and multiply that by, needs to be in terms of liters, we've got a total volume of 1,500 mils, which is the same as 1.5 liters. So if we take that 1.5 liters and multiply that by 55.5 grams per liter, then we're going to end up with 83 grams of protein. Okay? Now let's look at free water. Free water, we have 807 mils per 1,000 mils of formula. So if we take the 807 mils per liter, We multiply that by 1.5 liters, which is our total volume that we're getting in. Then we're going to end up with 1,210 mils of free water. Okay, so I'm going to go ahead and populate our sheet over here with what we've determined so far. So again, we've determined that there's 1,800 calories, 83 grams of protein, total volume was 1,500 mils, and our free water was 1,210 mils. Okay. So next is our calorie to nitrogen ratio, and we'll do that on another page. So the calorie to nitrogen ratio is basically you take your calories and you're going to divide that by your grams of protein, which you divide by 6.25. And again, the rationale for dividing by 6.25 is by weight, protein is 16% nitrogen. So if you take a number and multiply it by 16%, that's the same thing as dividing by 6.25. So you can do this either way. 6.25 is just what I learned first, so that's what I tend to use. So if we do the math here, we have 1,800 total calories, right? And we're dividing that by 83 grams of protein, which is what we have being provided, divided by 6.25. And when I do this math, I end up with 135.5. Now, the sheet that we have, and I don't think you can see it on here because I think I've got it cut off, but this sheet will tell you what the, I'm sorry, it does tell you, it's right here. It tells you it's 135 to 1, so why did we bother calculating it? Well, there might be times where you estimate somebody's calorie needs and you estimate their protein needs, and you're looking for the formula that's going to best suit their needs. So you could take those needs, whatever calorie needs and protein needs you have, and determine a nitrogen to calorie ratio, and then look at the different formulas that you have to choose from and find one that closest fits that. Again, it may not be as important depending on what the disease state is, but that's one place where you actually might have to determine that calorie to nitrogen ratio. So again, we calculated it to be be consistent here, 135.5 to 1. Okay? And now the last question, is the RDI met? Well, again, according to our sheet over here, it's going to be met at 1,200 calories or 1,000 mils. We will meet 100% of the RDIs. And we are at 1,200 mils and we're at 1,500 calories, so we are definitely meeting the RDIs. So that would be a big yes that we are meeting it. Okay, and that's basically how you use these sheets to calculate a tube feeding order.